What is going on, guys? Welcome to another video in my tutorial series for digital logic, and today we're going to be talking about the demultiplexer. And what a demultiplexer is, as you can already imagine, is the direct opposite of what a multiplexer is. And what a multiplexer does for us is take in two n inputs and spits out only one output. Now in a demultiplexer, we're going to take in only one input, and we're going to spit out 2 to the n number of outputs, and this is going to be the number of outputs is going to be controlled by our selector right here. All right. So this demulx is going to be referred to as a 1-2 demulx because this has one input, two outputs. All right. Now, if we had perhaps 4 of these outputs, we would then have to have 2 selector lines, and this would be called a 1-4 demulx. All right. And this the same as a multiplexer in the sense where only one of these 4 lines can be selected, can be active at any point in time. Alright, so I'm going to go ahead and draw a truth table here, but before I do that, I want to, draw a little diagram here. I for input. This is going to be a 1 to 2. Alright, and I'm going to label this as our selector here. Alright, and let's begin our truth table. So the first thing I want to do is put the value S here, because that is going to be our only input that actually controls the output. Alright, so we have this, and you'll see why in a minute. And let's list our outputs here. We have Y0, Y1. Alright, and S only has 2 possible values at any point in time. We have 0 or 1. Okay, and when S is set to 0, we want the value of I to be transferred over to Y0. So Y0 would then have the value of I when I is set to 0. When S is set to 0. Okay? So Y1 would be set to 0. Now when S has the value 1, this has to be connected to Y1. So when S has the value 1, we want Y1 to have the value of I, our input. And that is our truth table. Now, since we have 2 outputs here, we're going to draw 2 little functions to represent each one of these outputs. Okay? Now, let's start with Y0. Now, Y0 is basically going to have this. Let's start with our first row right here for Y0. When S is set, when it's not S, or when it's 0, so we're going to write S right here, not S, and we're going to write the value I right here. And we're going to add it with the next value, S and 0. Now let's take a look at our second output here. We have Y1, which is going to have the value of 0, 0, so S and 0. And we are going to have the value of, not S, S and I. Alright, so if you look at this, this comes directly from our truth table here, okay? And the one thing I want you to notice right away is S and 0 is going to give us a value of 0. Same goes for this. Just think about that for a minute. If we have an AND gate, and if one of these values is 0, it does not matter what this value is. The output will always be 0. And that is where we get that right there. Alright? Now, let's go ahead and draw our circuit diagram. And the way I'm going to do that is, let's start with our selector here. And I'm going to draw a selector. I hope you can see it. S. And I'm going to have a NOT gate, I'm gonna have our inverter here and our regular. Okay, so this is able to give us the value of 0 or 1 at any point in time. All right. Now we have our two outputs, correct? Oh, and before I go on, we need our input. So we're gonna put our input here, and since we only have one input, so there we go. Now our input is connected to both y0 and y1. So I'm gonna go ahead and draw our little AND gates here. And the reason I have AND gates here and not whatever other gates is because of this. This is because when this is set to 0, the only thing that matters in y0 is these two values right here. And same goes for y1. So we have our two AND gates here because this is the representation of an AND gate. We know for y0, let's call this y0, we'll call this y1. When y0 is set, we need to have the value of not s and I. So let's do that. We'll connect the value I right here. And we need the value of not s. And this carries the value of not s. Okay? With the not gate right there. Now, as far as the y1 goes, we need I to be connected. And we need s to be connected. And there you go, ladies and gentlemen. This is how you construct a demultiplexer. I hope you guys enjoyed this video, and if you did, please don't forget to hit that thumbs up, comment and subscribe, and I'll see you guys in the next video. Bye-bye.